in the previous video, we did some fake analysis. And we found that your algorithm runs 3n squared plus 8n plus 9. My algorithm runs 100n squared plus 4. And we said, hey, which one of these is going to win? All right, which game of golf algorithms we want the smallest or the least growing one. When all the work was done, we came out with this constant, or I guess technically it's a scalar. We have 3 over 100. And, oh, look, the 3 means that you're taking up less time than me. I'm taking 100. You're taking 3. But the most important part is we're both in the same club of n squared. All right? We're in the order of fraternity n squared. Well, I want to actually graph these and show you what happens as we graph these and compare them, give you kind of a visual intuition of what's going on here. Let's put the analysis of our two algorithms in here and compare them. You are 3n squared plus 8n plus 9. And mine is 100n squared plus 4. There we go. And then, again, we don't care about the negativity. We're only caring about this upper right-hand quadrant because that tells us we're going to have a positive number of items in our data set. And then how do the algorithms grow? Well, it doesn't look like either one of us is doing real good here. But just for tickles, let's zoom out here and ooh, look at yours. Okay, 3n squared. Ooh, it's growing slower than mine. And you'd almost say that, yeah, let's go with your algorithm, which, yeah, if these were only two choices, yeah, let's choose yours. But do you notice as I go up further and further and further, in fact, let me zoom out. And then let's see, can I stretch this? Oh, it's either out or in. Okay, let's zoom out, and then I'm going to go up and up and up. You notice as we get to these really large numbers, which, by the way, it didn't take very long to get there, and it looks like we're hanging out at about 100. Your line and my line look parallel. So, yeah, early on, if we go home here, it's like, oh, yeah, let's use your algorithm. Nice and green. And look, it's taking less and less time. But then as we got bigger and bigger and bigger, it's just kind of like, well, yeah, I might beat you to the stoplight, but that doesn't mean you're very far behind me. So I actually want to graph these as a ratio. Remember in the previous video, I wrote these as ratios and we canceled out a bunch of terms. I want to graph them as ratios. So I'm going to put parentheses here for the top. And then I'm going to just grab this, Control X, and I'll say divide that by this. And everything's gone over here. Let's click home. And oh, look at that. This little humps here is kind of interesting because we could talk about asymptotes. Anyway, a little hand waving there. Look what's going on with that green line there. Okay, can we zoom in so you can see the green line a little better? Zoom in, zoom in, zoom in. That green line nearly, I call it a line, but it's not a line. But it looks like a line, doesn't it? As I move to the right. As n gets bigger, meaning I'm moving to the right here, our green line approaches some value. Now, look, we're only in the 30s here. But let me zoom out a lot. And now, oh, look, we have larger steps here, 2,500, 3,000. Ooh, I can keep going. Woo, really big numbers, really big numbers. Okay, well, let's pick on one here, 340,000. All right, zoom in, zoom in, zoom in. Zoom in, zoom in, zoom in. Zoom in, zoom in, zoom in. We are zooming in. We are zooming in. What is happening to our green line? I don't charge any extra for the singing, by the way. What are we approaching? Okay, I'm going to just keep coming in here. And it looks like I've maxed out the calculator, but that green line is not 0.03, but oh, it's so close. It's so close the calculator won't even zoom in anymore. 0.03. Hey! Didn't we do a bunch of math in the previous video and we came out with 3 over 100? Well, 3 divided by 100 is 0.03. That means as we do our two functions as a ratio, the limit as n got really, 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 really big, which I'll write as infinity, is 0.03, which means it's a constant, which means we're in the same club, right? The same order. And our club, in this case, is n squared. So I just wanted to graph that to you. The last video we did the math, which is great. So I think it's nice to visually see this. We did it in the math, and now we did it graphically. And we have some more to talk about as far as growth rates, big O and big theta. But let's keep moving forward. See you in the next video.